All right, we're going to look quickly at some linear transformations, mainly stretches and compressions. And so what we're going to do is this way overcomplicates it. And so when we're looking at this, when it talks about transformations, it's going to say stuff about input and horizontal and vertical changes. All we're going to look at is we'll say a change to the slope causes a vertical change. So we're not worrying about first part. Then it's going to be a stretch or a compression. It's a transformation that creates a steeper or a less steep slope. In the function, and it uses multiplication. So on this, we can talk about vertical and horizontal. It means the same thing. If we're taking and stretching something horizontally, stretching it this way, think of like taking slime or putty and pulling it, it stretches so it gets taller that way. And if I compress it, it's going to get flatter this way. Well, whatever I'm doing that way, the opposite happens horizontally. So if I pull it this way, it's stretching horizontally, but gets flatter this way. So they're opposites of one another, which means one of them doesn't really matter. Okay, so we're not really worried about horizontal transformations on this. If it's a stretch here, it's just a compression there. So when I have this is going to be vertical stretch. And mainly we're focusing on one because it's enough to just get down what it's doing vertically, stretching or compressing. And if we get to like, we really understand it, then whatever's happening, like if I pull it, it goes farther up faster this way, then it's going less the opposite way. So they're just opposites. We'd say this is a vertical stretch, slope of 3, because I've got a 3 there. Well, if we were to look over here, it's a horizontal compression, but the slope is still 3. Okay, so same thing happens. On this, the y-intercept doesn't change. Okay, and that would be the main difference between this is where we've got the multiplication. This one, the y-intercept wouldn't change. This one, the x-intercept would not change. But if the way that we work it out, if we get a couple points on it, it works out fine for us. So if I do a slope of 3, 1, 2, 3 over 1, or down 3 to the right 1, that would be this line right here. Okay, so that gives us our vertical stretch. And then on the bottom part, we have a vertical compression. Which is a slope now of 1/2, which means from here, instead of going up 1 to the right 1, I go up 1 to the right 2, or down 1 to the right 2. And we get a line something like that. Okay, so it's less steep, and it causes the input or the output to be multiplied by this number. So whatever I've got, however it changes it, it causes it to be multiplied by this. So really we just see this as like y equals 3x, or y equals 1/2 x. That's what our slope does, is it takes it and tilts it along a point to make it steeper or less steep, just depending on what it is. So if a, or the number in front, so we'll call it a, or we could say it's m, because really it's just the slope. If it's between 0 and 1, it's a vertical compression. Or we could say it's a horizontal stretch, if we're looking opposite of those. And if I have a is greater than 1, or the slope is greater than 1, it's going to be a vertical stretch. So more steep. And if it's a vertical stretch, it'd be the opposite, horizontal compression. Okay, so just a quick overview of that. Really, it's something we do naturally, we see naturally, and so don't want to overcomplicate it from what it is. So on this one, instead of saying it's like input changed or output changed, we're just going to say, is it a vertical stretch or vertical compression, and kind of go from there. Okay, so I'm going to say this one would be a vertical stretch, and that's a slope, and let's just put m for slope. Slope of 6. Okay, so vertical stretch, I'll say that makes it steeper. And so again, vertical stretch, the slope of 9 now, and still making that steeper. Okay, now it's in the parentheses, but we'll still talk about it vertically, vertical compression, slope of 0.75, and it's a compression because it's less than 1, and it's less steep. Okay, so again, and we've got a fraction here, but notice that fraction's bigger than 1, so that's going to actually stretch it. And if we did a slope of 4/3, we can use this up here. If I go up 1, 2, 3, 4, to the right 1, 2, 3, it does stretch that just a little bit. Okay, so not very much, but it does make it steeper. And that slope was 4/3. And my 2/5 finally is a vertical compression, which is slope of 2/5 and is less steep. Okay, and we'll look at one vertical compression, vertically compressed by a factor of 1/3 to create function t. So we would just say y equals 1/3 x, or if the parent function, if we wanted to get real technical with it, we'd say t of x in function notation equals 1/3 times f of x. And so that's just relating two functions together. But we're really focusing on this, understanding that that's a stretch and a compression, so that way when we look at this in terms of how are the lines moving, left, right, up, and down, then we have the stretch and compression as well. That gives you every possible way to move these lines to get any linear function that you could possibly have.